Greetings everyone. We will be taking you through the process of planning an entire electrical project. Now this will be a sample. So what I have here is a sample plan, a sample floor plan of a 2-bedroom house. And to go straight ahead into identifying the parts of this building, as you notice here is the porch, and you enter into the living and dining room. Enter here, that's the bathroom, and then over here is a bedroom. On this side is another bedroom, and over here is the kitchen. Take note of the legend. P for plug, S for switch, PNL for panel. That little circle for lights, this symbol for window, this symbol for the potted, a symbol for the meter pole, and a symbol for air conditioner. And that's how plans are done. Whenever you making up your plans, you can use symbols and have a legend to show what represents what. In that way others can read your plan. The scale of this plan is 1/4 inch equals 1 foot. So 1/4 inch on paper equals 1 foot on the ground. The size of each of these rooms are going to assist us in determining the length of the conduit from point to point, the amount of cable that we'll be using, and so on. This plan is like a treasure box full of information, because this is where you will find the information to draft up your material list and to count up the amount of plugs and lights and other points that you will need to put in and what you will be charging for. Now, how many points do we have here? Let's count the lights and see the amount. 1, 2, 3, 4, 5, 6, 7, 8, 9 lights. How many plugs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 plugs. 1 plug for the kitchen will be a GFCI plug. Also 1 for the bathroom. Or let me just say 2 for the kitchen is a GFCI plug. And 1 for the bathroom is also a GFCI plug. We have 1 air conditioner, and that's in the larger bedroom. And here is the distribution panel. This is where it will be located. For the switches, we have 3 switches at the door, so it will be a gang of 3 switches, and it will control the porch, outdoor, and also the living room. So when you enter, you can turn on the porch light, you can turn on the outdoor light, and you can turn on the living room from this point. Now, the outdoor light at the back will be controlled by this, one of this. There is 2 here. One will also control the kitchen light. And then we have 1 for the main bedroom, we have 1 for the bathroom, and then we have another for the smaller bedroom. Now, notice the metering system. As indicated here, this cutoff line, it shows that this is not the exact distance. It's longer. but this cutaway allows you to see how far it goes. We have 20 feet. The meter pole is located 20 feet away from the building. And as you can see, when you see two potheads, you know that it will be an overhead wiring. If you see one pothead, it would mean that the wire comes in and then goes through the meter and then goes underground into the building. But in this case, it will be an overhead wiring. How I make up my plan is I would copy it from a blueprint, copy it from the original blueprint to allow myself to some clarity. Because most times the blueprint, I don't want to write on it. And my plans, I am active in drawing stuff on them and to take measurements for my work. So how I normally get my plans done is I would normally copy it from the blueprint, or I would go to the site itself. In a case where that they don't have a blueprint and I would need to make up a plan for myself, I would measure the size of every room and determine where each point will be placed. That is, the plugs, the switches, the panel, the lights. And that's it. Just know the size of every room in that building, the size of the entire building. Also know where the windows will go and the doors. So I would do up a rough sketch of the building itself, just writing out where the doors will go, the windows will go, the distance between everything, and the measurements. And then when I come home, I would just draw up the building with more accuracy. Sometimes when I'm on the site and a person says, for example, a person calls me to wire their house, and when I'm on the site, they see me measuring up the building itself, the entire building. And then I ask where that plug will go, where that plug will go. But they don't see me measuring from plug to plug. No, I don't do that at the site. I just get the size of the building, the points, etc. to draw out the plan, and then I will take care of all of the measurements for all of the equipment to wire the house from office. Now, in order to arrive at a properly completed material list, these are the things that we will aim at accomplishing. We need to find out the maximum electricity demand for this installation. That is the total current that each circuit will be using, even the entire building will be using, the size main breaker for the entire building, the size main cable for the building, and the size distribution panel that we'll be using. And other stuff on the list will include whatever is necessary for everything to work safely and neatly. When we try to fill all of these, we will have a complete material list. Now let's do the calculations to put together the necessary material for the lighting circuits. And we said that we have 9 lights in this building. So let's put it up here. 9 lights. So we have 9 lights in this building. So how do we know the total current that these lights will be using every day? Now this is table 13 of the JS21. To understand table 13 a bit, you notice up here It says the estimation of the maximum demand of an installation for use in computing the size of cables for service mains and sub-mains. And it tells us to see Article 6, 15, 2D for more explanation. What we want from this is the lighting circuit. That's what we're working on. And our building falls under individual domestic installation. It's just a house. And it said it would include individual flats of a block of flats. So it would include a house and a scheme. A single house and a scheme. So this is for single dwellings. This column. Now for lighting it says 66% of the connected load. That's the factor that we will be applying to the lights. So it says for any given point in time, the most lights a person would normally have on is 66% of the lights. Now we will assume that all the lights are 100 watts because that's the highest domestic light a person would purchase for their home. Multiplied by 9 lights. So that's 9 times 100 watts. And we know the formula to calculate current because that's what we're trying to achieve, the total current. And the lights will be using 110 volts. Let's calculate that. Now let's apply the 66%. .4 amps. Now for the purpose of load balancing, because we know that domestic installations today are being wired for 220. No longer are we using 110 for a house. So in order to balance off the load and both of the live wires coming in from the main, we have to divide up the current that will be shared among the circuits. Hence, current per phase. And how we calculate the current per phase? We just divide the 5.4 amps by 2. And we use our calculator. Next, we need to know how much current each lamp will be drawing at max. All of this information, we will see the value of it when determining what we need for our material list and how we will be wiring the building. Now the current per lamp on each phase is by the amount of lamps. And just a point of note too, that each time you're doing this calculation and you do the current per lamp, you will always arrive at 0.3 amps. Next is the amount of current that each circuit breaker will be carrying. Now, the amount of circuit breaker in the building is our decision. However, the maximum circuit breakers on the maximum lights to be placed on a lighting circuit breaker is 12. We normally don't max them out. In our case, it's 9 lights, so we are nowhere near max. So we will be using one circuit breaker. One circuit breaker, current per lamp, times so we're right back where we were because it's only one circuit breaker we're using. So that one circuit breaker, that's the amount of current. So here is our material list. This is a whiteboard of our material list that we'll be compiling. And so far, 115 amp single pole circuit breaker for the lights. Reminder that our house will be requiring 12 plugs. For plug sockets, our JS21 says, notice over here it says, plug sockets not protected by a non-adjustable circuit breaker as per 6.16, that's the article that we can refer to. It says one plug socket, if it's a single plug socket we're installing, we just rate that at 100%. So if it's a 15 amp, we would say just call it 15 amp. Now when it says 2 to 6 plug socket, when we have between 2 and 6 plug sockets, 100% of the connected load of the largest plug socket at 25%, and 25% of connected load of the other. So if you had between 2 and 7, that's 2 to 6, we would take out 2. We would take out 1 and say 100% of the connected load of the largest and 25% of the rest. But in our case, it's 7 or more plug sockets. Now, In our case, 7 or more plug socket, 100% of the connected load of 2 of the largest plug sockets. Notice 100% of the connected load of 2 of the largest plug sockets plus 10% of the sum of the connected load of the other plug sockets. In our case, it's 12 plugs, so we're going to take out 2 and add the rating of 15 amp and apply the 100% to that. That would give us 30 amps, and the rest we just add up the amperage and apply the factor of 10%. So the first two at 100%, and the rest 10 at 10%. First two at 100%. Now plugs are rated in amps, and one domestic plug socket is rated at 15 amps. So multiply that by 2, we get 30 amps. And the rest, which is 10 at 10%, that is 10 times 15 equal 150 times 0.10. Now we add them. It's 45 amps. That's the total current for plugs. Now reminder, for the purpose of sharing up the current among the phases, that is the main lines that are coming in, we have to split the phases. So that's 45 amps divided by 2. Use our calculator. That's 22.5 amps. How much would each plug be carrying on average? That's the 22.5 amp. That's the current per phase divided by the amount of plugs. Use our calculator. So each plug will be carrying 1.8775 amps. So we have a total current of 45 amps, current per phase of 22.5 amps, current per plug 1.875 amps. Now notice how we will be dividing up the circuits. Circuit 1 will be the kitchen circuit, and so I'm gonna put the 2 over the counter plugs, that is here and here, for the kitchen circuit. We are putting those 2 on 1. In the bathroom circuit, we will be putting it by itself on one circuit. Now these are GFCI plugs. Now the GFCI plug, as you know, it's for moisture conditions. Now the maximum amount of plugs that can go on a GFCI circuit is 2. So for the kitchen, the max on a breaker is 2. The same for the bathroom. Now, for the purpose of being able to switch off one area when we switch one breaker, we just put these two on one, so that when you switch the breaker off, all the counter plugs will be off. And for the bathroom, when you switch that breaker off, that plug will be off as well. Instead of putting these two on one and these two on one. So when you switch off the bathroom circuit, the kitchen circuit will be off. We won't be doing it that way. We want the bathroom to be off when its breaker is off, and the kitchen counters to be off when its breaker is off. So here, bathroom, kitchen counter. These are for kitchen counter. And for the purpose of knowing the numbers, this circuit will be joined. This is what each circuit will be joined. Now the main bedroom, the larger bedroom, will have 3 plugs on its circuit. One from the kitchen, this one will be controlling the refrigerator, and another 2. Actually, the maximum for regular plugs on a circuit breaker is 5. But we normally don't max them out. We normally put a max of 4 on them, and later on, if there are any additions, 1 can go on, and we won't be running the breakers at max. Now in this case, we have 1, 2, 3 on that circuit breaker, and they are in the same general area. So if you switch that breaker off, 1, 2, 3 will go out. For the living and dining room and the porch, we have 4. 3 in the living and dining room and 1 on the porch. And for the smaller bedroom, we have 2 plugs and a circuit breaker. Now, we want to bear in mind that all of this current, when we add it up, we will get the current per phase. And the current per phase, that's the amount of current that one line of the 2 phases coming in from the main will be carrying in. If it was a 110 wiring, they will all be coming in through one line.